One of the brightest stars in your night sky is dying, right now, and it has been hiding a secret for over 100 years. We just found it. Betelgeuse, the giant red star perched on the shoulder of the hunter Orion, one of the most recognized stars in all of human history, is not what we thought it was. It is not alone. It has a companion nobody could see. And that companion may be the reason behind everything strange that Betelgeuse has ever done, including the shocking event in 2019 that made the entire world believe a star was about to explode and blaze across our sky like a second moon. Astronomers have been watching Betelgeuse for centuries. They named it, mapped it, studied it, argued about it. And for all of that time, a secret was hiding right beside it, so close and so faint that our most powerful telescopes could not detect it. In December 2024, that changed. And what they discovered when they finally looked hard enough was bigger, literally bigger than anyone had ever predicted. This is the story of the most dramatic, most bizarre, most world-stopping discovery in the history of one of the most famous stars in the sky. And it is all happening right now. Let us start with what Betelgeuse actually is, because the numbers are almost impossible to hold in your head. Betelgeuse is a red supergiant star sitting roughly 650 light-years from Earth in the constellation Orion. On a clear night, you can spot it with your naked eye. It is that distinctly reddish-orange point of light on Orion's upper left shoulder. It has been there every winter night for all of recorded human history. Ancient Egyptians saw it. The Greeks built Orion around it. Every civilization that ever gazed up at the winter sky has seen this star. But we are only just now beginning to understand what it truly is. Betelgeuse is not just big. It is enormous in a way that makes every comparison feel completely pointless. The sun is massive. So massive that over 1 million Earths could fit inside it. You already know that. But here is what you probably have never heard. If Betelgeuse replaced the sun at the center of our solar system, if you simply swapped it in, the surface of Betelgeuse would stretch beyond the orbit of Jupiter. Earth would be buried deep inside the star. Mars would be inside the star. The entire asteroid belt would be swallowed whole. And Jupiter, the largest planet in the solar system, would be grazing along the outermost layers of the star's atmosphere. That is the scale of what we are dealing with. Betelgeuse is between 700 and 1,000 times wider than our Sun. Its diameter spans over 1 billion miles. It radiates more than 100,000 times the energy of our Sun. It is one of the largest and most luminous stars visible to the naked eye from Earth. And it is dying. When stars as massive as Betelgeuse exhaust their fuel, they do not simply fade away. They explode. A supernova, specifically a core collapse supernova, is what awaits a star like Betelgeuse at the end of its life. The nuclear furnace at its core runs dry. Nothing remains to push back against the crushing weight of the star's own colossal mass. Gravity wins. The core collapses in a fraction of a second, and the resulting shockwave tears the outer layers apart in an explosion so violent it briefly outshines entire galaxies. When Betelgeuse finally goes supernova, it will be visible from Earth, in broad daylight. Not for a moment, for months. It will blaze as bright as a crescent moon in the night sky. It will be the most brilliant object in the heavens, second only to the sun. Every single person alive on Earth at that moment will be able to look up and see it. No telescope needed, just eyes and a clear sky. That moment is coming. The only question is when. For most of history, scientists believed that question had a comfortable answer. Betelgeuse is near the end of its life, yes. But in cosmic terms, near is relative. Estimates have ranged from a few thousand years to as many as 100,000 years before it explodes. That is a long time by human standards, long enough to sleep easy tonight. Then late 2019 arrived, and Betelgeuse began doing something it had never done in nearly 2 centuries of recorded observation. It started going dark. Not slowly, not gradually, dramatically. Between October 2019 and February 2020, Betelgeuse lost more than 2/3 of its visible brightness. A star that had ranked among the top 10 brightest in the night sky since before recorded history suddenly plummeted so far it was barely recognizable. By February 13th, 2020, it was the faintest it had been in 200 years of scientific observation. Stargazers noticed it. Amateur astronomers noticed it. And within days, the story was everywhere. Was Betelgeuse about to explode? Was this the beginning of a supernova? Were we on the verge of witnessing the most spectacular cosmic event in all of human history? The world held its breath. Scientists scrambled. Telescopes across the globe swung toward Orion. Papers were written. Theories flew. Some said it was a cool, dark patch on the star's surface, like a giant sunspot, but covering a quarter of its visible face. Others said the star's pulsation cycle had caused it to temporarily shrink, and some, cautiously, nervously, whispered, "Maybe this is actually it." But it was not a supernova. By April 2020, Betelgeuse began recovering. Brightness slowly returned, the star came back to normal, and the world exhaled. Then scientists got to work uncovering what had actually happened. And the answer was something so bizarre that researchers openly admitted they had never seen anything like it in a normal star's behavior, ever. Betelgeuse had literally blasted off a chunk of its own surface. Here is what happened: a massive convective cell, a bubble of superheated gas rising from deep inside the star, much like bubbles surging through boiling water, broke through the surface of Betelgeuse and was hurled into space. Scientists called this a surface mass ejection. The material that erupted was no thin cloud. It was a colossal plume of hot plasma more than 1,000,000 miles across, screaming through space at 200,000 miles per hour. A piece of the star's own surface, ripped away and flung into the void. Our sun does something similar, but on a far smaller scale, called a coronal mass ejection. It is when the sun's outer atmosphere launches a cloud of charged particles into space. It happens regularly. It is a well-known phenomenon. We even issue storm warnings for it, because powerful ones can cripple satellites and knock out power grids on Earth. What Betelgeuse did was 400 billion times larger. The ejected material traveled outward from the star, and as it moved away from that intense, searing heat, it cooled. As it cooled, the heavy elements in the gas, silicates, dust grains, condensed. The gas transformed into a dark, thick cloud of dust. A cloud so enormous it covered roughly a quarter of Betelgeuse's visible surface from our perspective here on Earth, blocking the starlight behind it. That is why the star went dark. Not because it was dying, not because it was about to explode, because it blew a chunk of itself into space, and the debris hung in front of it like a curtain, blocking our view. Lead researcher Andrea Dupre, an astronomer at the Harvard and Smithsonian Center for Astrophysics who has been studying Betelgeuse since 1985, stated plainly, "We have never before seen a massive ejection from the surface of a star. We are left with something happening that we do not completely understand. A star 650 light-years away hurled a piece of itself the size of a small planet, draped the debris across its own face, and baffled every astronomer on Earth." Betelgeuse had done something unique in the history of stellar science, and nobody knew why. Until very recently, when a stunning new discovery changed everything. For over a century, astronomers had suspected something. Not loudly, not with certainty, but as a persistent, nagging idea lurking in the background of Betelgeuse research. The star's brightness did not vary randomly. It varied in patterns. There was the well-known roughly 400-day cycle, where the star pulses brighter and dimmer as it breathes in and out. But there was also a longer cycle, about 6 years, that nobody could fully explain with the pulsation model alone. Some researchers proposed that this 6-year cycle might be caused by something orbiting Betelgeuse, a companion star, a smaller star sharing Betelgeuse's gravitational grip, its orbit tugging at the supergiant, influencing its brightness, perhaps even clearing dust in its path, making the star appear brighter to us during certain parts of its orbit. But Betelgeuse is so brilliantly, blindingly bright that finding anything next to it is like trying to spot a firefly sitting beside a raging bonfire. Every attempt to search for a companion ended with the same problem. Betelgeuse's overwhelming light drowned everything else out. Searches were made. Nothing was confirmed. Decade after decade, the companion remained theoretical. Nothing more than a whisper buried in the data. Then, in 2024, 2 independent research teams published papers predicting something extraordinarily specific. Based on decades of brightness data, orbital mechanics, and careful modeling. Both teams concluded that if a companion star existed, they could calculate exactly where it would be in December 2024. That was the moment the companion would reach its greatest angular separation from Betelgeuse, the farthest point in its orbit, where it would be easiest to separate its faint light from the supergiant's overwhelming glare. A French astronomer named Miguel Montargès, working at the Observatoire de Paris, read those papers. He studied the prediction, and he decided to take the shot. He secured time on one of the most powerful ground-based telescopes on the planet, the European Southern Observatory's very large telescope, nestled in Chile's Atacama Desert, and pointed it directly at Betelgeuse in early December 2024. He used an instrument called SPA, originally engineered to hunt for exoplanets by blocking out the blinding light of their host stars and revealing the dim worlds quietly orbiting around them. The very same technique, the very same tool. now aimed not at a planet, but at a star. Montages spent months painstakingly processing the images, unsure whether the instrument was even sensitive enough to detect what he was searching for. He almost expected to find nothing at all. Then the processing completed. He leapt from his chair. There, in the processed image, where the supergiant's blinding light had been carefully stripped away, was a source. A faint, tiny point of light. A star, sitting exactly where the models had predicted it would be. Betelgeuse b, the companion. The star hiding in plain sight for over 100 years. The discovery was published in July 2026 in the journal Astronomy and Astrophysics, and it arrived with a stunning shock. The companion was nothing like anyone had expected. Earlier theoretical estimates placed its mass at roughly that of our Sun, but the imaging data told a completely different story. Betelgeuse b is 2 to 3 times the mass of the Sun, significantly larger than predicted. So large, in fact, that the planet-hunting post-processing techniques used to find it would have missed it entirely had it been any smaller. In an almost poetic twist, Betelgeuse b was discovered precisely because it was bigger than scientists imagined. If it had matched theoretical predictions, the team might have been chasing something too faint to ever detect. The companion revealed itself by being unexpectedly, almost defiantly massive. It quickly earned a nickname, Betel Buddy. And here is where things get truly extraordinary. Because Betel Buddy doesn't just sit there quietly orbiting, it interacts. It leaves a wake. A separate study published in early 2026 used data from the Hubble Space Telescope to reveal something incredible. As the companion orbits through Betelgeuse's vast extended outer atmosphere, and it's so close it's literally moving inside the supergiant's outer layers, it creates a dense wake of gas trailing behind it. Like a boat cutting through water, the gravitational pull of the smallest star drags material along as it moves, piling it up, carving a visible trail through the stellar atmosphere. Hubble caught that wake, a gravitational ripple, spreading through a sea of stellar gas hundreds of millions of miles wide. Scientists now believe Betel Buddy may actually be responsible for the mysterious 6-year brightness cycle. As it orbits, it periodically sweeps dust out of the line of sight between Betelgeuse and Earth, making the star appear brighter. When it shifts to a different part of its orbit, the dust returns and the brightness fades. An entire astronomical mystery that puzzled researchers for generations, now potentially explained by a hidden companion nobody had ever directly seen. But there's an even bigger question now, sitting on every astronomer's desk. Could Betel Buddy have caused the Great Dimming? Think about that. The massive convection cell that launched the surface mass ejection back in 2019. Could the gravitational influence of the companion, passing close to the surface during its orbit, have triggered or amplified that catastrophic eruption? Could Betel Buddy have reached deep into the churning interior of Betelgeuse and set off the chain of events that blasted a chunk of the star's own surface into space? Scientists aren't ready to confirm it yet, but they are absolutely asking the question. The paper announcing the companion's discovery stated it explicitly. Astronomers are now desperately eager to learn whether this hidden companion could influence Betelgeuse's future evolution, or even alter the catastrophic way it eventually explodes. Now let's talk about what the James Webb Space Telescope is revealing in this incredible story. Because Webb isn't just watching Betelgeuse, it's reading it in extraordinary detail that no instrument in human history has ever achieved before. Webb observes the universe in infrared light, wavelengths completely invisible to human eyes, yet carrying information that visible light simply cannot. Dust, the very kind that caused the Great Dimming, is transparent to certain infrared wavelengths but blocks others, meaning Webb can see straight through dust clouds that completely hide everything from ordinary optical telescopes. And Webb can measure the temperature of surfaces and gases with breathtaking precision. The images Webb has captured of Betelgeuse reveal the star's surface dynamics at a level of detail that was simply impossible before. The surface is not smooth and uniform like a billiard ball. It roils and churns violently. Giant convective cells, some larger than our entire sun, rise from deep within, burst through the photosphere, cool, and sink back down. The surface of Betelgeuse is a raging ocean of boiling plasma, constantly in motion, constantly erupting in plumes and hurling material into space. Astronomers are using Webb's observations to track the motion of gas and dust around the star, to analyze surface temperatures in real time, and to search for the kinds of dangerous instabilities that might signal what is coming next. Webb can see the material Betelgeuse throws off, the dust clouds, the gas shells, the complex debris fields surrounding the star out to enormous distances. And Webb can analyze exactly what that material is made of, giving scientists stunning insight into what is happening deep inside the star, where we can never look directly. What Webb is building, observation by observation, is a portrait of a star in the final chapter of its life. A star burning through its remaining fuel, pulsating and erupting, losing mass at an astonishing rate, shedding its outer layers into space, surrounded by shells of previously ejected material. Each shell is a record of an earlier eruption, like tree rings silently recording the centuries. Every massive star that has ever exploded left behind those same haunting shells. Betelgeuse still has its shells around it, and we can study them live in real time. That is exactly what Webb is doing, watching the crime scene before the crime. And there's a jaw-dropping Webb discovery from 2025 that completely changes how we think about Betelgeuse's future. In June 2025, astronomers detected a supernova in a distant galaxy called NGC 1637, roughly 40 million light-years away. Scientists compared before and after images taken by Hubble and Webb. The star that exploded was a red supergiant hidden behind thick clouds of cosmic dust, so dusty that Hubble, operating in visible light, could not detect the progenitor star at all in the pre-explosion images. But Webb, piercing through an infrared, could see straight through the dust and detect it clearly. This was the first time a supernova's source star had ever been identified at mid-infrared wavelengths. This matters enormously for Betelgeuse, because Betelgeuse is surrounded by dust, material it has ejected over its long and violent life, including the dramatic dust cloud from the Great Dimming. When Betelgeuse finally explodes, that supernova shockwave will have to punch through all of that dust. Invisible light may look dimmer or distorted to human eyes, but infrared vision cuts right through it all. When Betelgeuse finally explodes, every detail of that catastrophic moment will be captured with breathtaking clarity, straight through the dust, from the very first instant. If Betelgeuse detonates within our lifetime, the data collected will be the most detailed, most scientifically priceless record of a nearby stellar death in the entire history of science. We are more prepared for this moment than any generation that has ever lived. So let's talk about what actually happens when Betelgeuse explodes, because the reality is far more dramatic than most people dare to imagine. The core collapses in less than a single second. One moment there is a star, and then the core, crushed beyond the limit of any known force, simply gives way. In under 1 second, the core shrinks from roughly the size of Earth to roughly the size of a city, just about 20 kilometers across, and the resulting shockwave tears violently through the rest of the star. The outer layers, hundreds of millions of miles of stellar material, get blasted apart in a catastrophic explosion. From Earth, the supernova will appear as a sudden, dramatic surge of light. Within days, Betelgeuse would be blazing in the daytime sky. It would cast shadows at night. It would shine so brilliantly that people could literally read by its glow. Every single person on this planet, across every culture and every country, would witness it with their own eyes. No telescope, no app, no special equipment needed. Just look up. It would remain visible to the naked eye for months, possibly close to an entire year. And the remnant, a vast expanding cloud of gas and debris, possibly with a neutron star spinning violently at its center, would haunt our sky for thousands of years afterward, much like the Crab Nebula, still visible today, 1,000 years after its star exploded in 1054 AD. And we are perfectly safe. At 650 light-years away, the radiation reaching Earth would be completely harmless. Studies confirm we would need to be within about 160 light-years for a supernova to pose any real biological threat. Betelgeuse is 4 times farther than that. No danger whatsoever. Just the greatest light show in the entire history of human civilization. Now, when does this actually happen? The honest answer is, nobody knows precisely. Estimates range from a few thousand years to perhaps 100,000 years from now. What we do know is that Betelgeuse is behaving in deeply unusual ways. The Great Dimming was extraordinary. Surface mass ejections of that scale had never been documented in a normal star before. The discovery of a hidden companion raises stunning new questions about the star's evolution. The violent churning visible on its surface reveals a star in serious internal turmoil. Whether that turmoil is the final act or just a dramatic middle chapter, that is exactly what scientists are racing to figure out. And there is something deeply strange and beautiful about this moment in time. Humanity has been watching Betelgeuse for thousands of years, and for almost all of that time, it was just a red dot in the sky. Then came telescopes, then space telescopes, then the most powerful eye ever built. And right when we finally have instruments capable of truly reading what Betelgeuse is doing, The star seems to be putting on the most extraordinary performance of its entire existence. We built our greatest eye, pointed it at the most dramatic star in our sky, and discovered that the star had been hiding a secret companion, had erupted in a previously unknown way, had concealed a mystery that century after century of astronomers had completely missed, and may be approaching a grand finale, one that will write its name across our sky in fire and light. There is one last thought worth sitting with. The light we receive from Betelgeuse right now, the light captured by infrared detectors, the light amateur astronomers photograph on winter nights, left that star approximately 650 years ago, around the year 1375. The 100 Years' War was tearing through Europe. There were no telescopes. There were people gazing up at the same red star we observed tonight, and the light they saw, and the light we see, left the star in completely different eras. Here is the staggering reverse of that. If Betelgeuse's core collapses tonight, in this very moment, we would not witness the supernova for another 650 years. The light may already be traveling toward us, or it hasn't happened yet, and we cannot know which. That supernova could already be racing through the cosmos right now, and we simply have not received the news. That is not a frightening thought. It is a deeply humbling one. The universe operates on timescales and distances that make our entire human experience feel breathtakingly small. And yet, here we are, a brief, fragile species on a small planet orbiting a very ordinary star. We built the James Webb Space Telescope. We pointed it at a dying giant 650 light-years away. We discovered its hidden companion, and we are watching in real time as it approaches its end. Whatever Betelgeuse is doing right now, erupting, pulsing, being pulled by its companion, shedding its outer layers into the dark. We are the first beings in the known history of the universe to watch it closely enough to truly understand what we are seeing. That star has been dying for millions of years, and we finally showed up to witness it.